Greetings, detectives. Mrs. McKay here, and it's time for us to begin our case 6, which is all about motion. And we're going to start with clue 6-1, which is about rigid motion transformations. And this is just a quick little intro to the 3 different types. So let's start by filling in our learning target that says, I can identify and describe the, go ahead and write rigid I can identify and describe the rigid motion transformations of, and we're going to write 3 different types that we're going to learn. First one is called translations. Next one is reflections. And the last one is rotations. So these are 3 different types of transformations that we're going to learn how to identify and describe. All right? So I can identify and describe the rigid motion transformations of translations, reflections, and rotations. Let's start off by going over a little bit of vocabulary. So, what's a rigid motion transformation? Well, a rigid motion transformation is basically taking an image, whether it's a point, a line, or a figure of some sort, and making a perfect copy of it. Making a perfect copy. So it is making a copy of a shape, a line, even a point. And it's, think about when you copy and paste something on your computer. We copy it and then we paste it somewhere else. That's really what we're doing. But we have 3 different ways that we can make a copy. And that's what we'll be talking about with our 3 different types of rigid motion transformations. But the main idea is that we make an exact copy. Same size, same shape. Okay, same size and same shape. Okay? Now, the next vocabulary word that we want to know is pre-image. And pre-image is always the image that we start with. It's our start. Okay? It's our starting point. It's this starting image. And then our copy, the thing that we make when we make a copy of it, that's called our image. Okay? So that's our copy. Okay? So we've got a pre-image and we've got an image. The pre-image is our starting image and our image is the copy. All right? Now, let's talk a little bit about our first type of rigid motion transformation, and that is a translation. Now, a translation, if you look here at this purple rectangle, is just taking every single point on your image and moving it the exact same way. Each one is moved the same way. It's basically taking it and sliding it over. All right, so this dark purple is our pre-image, and our image is this light purple. Notice that what we did was we picked up, let me see if I can make a few points. The best way to think about translations is if you take your vertices or your points. So there's one, there's one, there's one, and there's one. And you move each one the same direction, same amount. So if I take this point and I go up 2 and over 1, 2, 3, 4, 5, 6, 7, I get to this point right there. Okay? And that means that I'm going to do the exact same thing with the next point. I'm going to go up 2 and over 1, 2, 3, 4, 5, 6, 7, and I get there. And then I take my next point and I go from here up 2 and over 1, 2, 3, 4, 5, 6, 7. And then my last point right here, I go up 2 and over 1, 2, 3, 4, 5, 6, 7. And you can see that each point corresponds and does the exact same amount. We go up, let's see, up 2 and over 7, and then the green one is up 2 and over 7. You get the idea, right? The orange one up 2 over 7. Each one's up 2 over 7. So basically we've picked up our image, we've shifted it up, and then we've shifted it over. So we've gone up 2 and to the right 7. Okay? Or we could say we go to the right 7 and up 2. One way that we notate this is we say the transformation of each point x, y, okay, translates or goes to, let's see, we went x plus 7, right, because we went to the right 7, and y plus 2. We went up 2. So we took each point of the image and so if this point right here was xy, then the corresponding point would be x plus 7, y plus 2. See that? Okay, so that's a translation. Translations are probably the easiest. You're just kind of sliding them around, okay? You're just sliding them around along a coordinate plane. Next one is called reflections. Reflections. Now a reflection is like looking in a mirror. It's reflected over a line. So imagine this dotted line right here being our mirror. And what we've done is we've actually taken each point. So let's do each point here again. Here's a point. And I'll change this color to this right here. And we'll do this one in purple. We've taken each point and we've said that it is equal distance from this line, this kind of a line of symmetry or a reflection line. So notice that this purple point is 2 away from this reflection line, from this mirror. So I'm going to go 2 over on the other side and make a point. And then I'm going to do the same thing for the green one. So this green one is 1, 2, 3, 4 away from the line. So I'm going to go 1, 2, 3, 4 away from the line. And I've made my green point. And then my blue one is 1, 2, 3, 4. So again, 1, 2, 3, 4, and there's my blue. So notice that it sort of has flipped. It's done a little flip, right? That's what a reflection does. The items that are closest, it's not a translation. We didn't slide it over the line. We flipped it over the line. It made a mirror image. Okay, so that's a reflection. And reflections always have this reflection line. Sometimes when we are going to reflect something, it's going to, if it's horizontal, if it's going to go vertically, it's going to, or horizontally, it's going to flip over a vertical line. Then notice that our y's all stay the same. So if this was x, y, right? This x is actually, this one over here is going to still be the same y, but it's going to be a different x. It's actually like if this was the origin, like if we say this was right here, then this would be, actually this one would be negative x, and this one would be positive x, and this would be y. Do you see that? So this right here, think about if this was 0, right? This would be negative 1, 2, 3, 4, and this one would be positive 1, 2, 3, 4 if we were labeling the points, and the y's stay the same. Do you see that? If we wanted to do the kind of pinky purple one, this say, let's just give it a point. If this was 0, this would be negative 2, and let's just say it's negative 2, 1, and then this one would be 2, 1, right? And then the green would be negative 1, 2, 3, 4, negative 4, and this one would be positive 4, but the y's would be the same. Okay, so reflections, if they are reflected over a vertical line, they keep the same y value, but the x's change. One's the negative of it, right? And if we were going to reflect it over a horizontal line, if you think about creating this exact same image right here, this red image, if we were going to flip it, say, over this line right here, let's say it was this line right here, this was a line going this way, and we were going to flip it this way, then we would take this point, which is 1 away. Now notice our x's are staying the same, but our y's are changing, and then we would go 1, 2, 3, 4 away, 1, 2, 3, 4 away, and then this one would be here, and then we would connect our lines like this. And you can see that we've just reflected over this line right here. Okay, so that's a kind of a vertical reflection over a horizontal line. So those are reflections. Now I think that translations and reflections are probably the easiest. The thing that I think is the hardest are rotations. Rotations are all about turning around a circle or around a point, okay? Making this circular movement around a single point. So let's take a look at this blue triangle, this dark blue triangle. And this happens to be a 90 degree rotation. And what I want you to look at is I want you to look at each point on this, we've got on this triangle, we've got this point, we've got this point, we've got this point. All right, so we've got a blue point, we've got a green point, and we've got a kind of reddish color point. All right, so we've got these 3 points, and if we took, and then we've got this black dot, this black point right here. All right, now I want to rotate this dark blue triangle, and I'm going to rotate it 90 degrees. And the way that I do that is I connect my red point to my center point, the center of my circle. And so that's what you see here is this dotted red line coming down. And then I make a 90 degree angle. I basically move this line 90 degrees, has to be the same distance from here to here and from here to here, it's like a radius. We're going to take it and we're just going to shift that whole radius 90 degrees, and we're going to make our new point, which is right here. So we've taken this point, this red point, and we've rotated it 90 degrees around to here. Okay? And then we're going to do the same thing for our green point, which is right here. So we draw our line down to our center point, and then we're going to take this line and we're going to rotate it all the way around 90 degrees. Again, we're making a 90-degree angle, and we end up right here. Okay, so it's actually it's moving, it's rotating around, and these two green lines are the same distance. It's a radius of a circle. And then we do the same thing with the blue one. We've got this blue point. We draw a straight line from the blue point to the center point. That distance, we're going to make it be the radius of a new circle, and we're going to rotate around, and we make a new right angle, and we end up with our 3 points. So we've got our red, our blue, our green. We connect our points, and this blue, dark blue circle or dark blue triangle has now been rotated 90 degrees over here, and so this pre-image became this light blue image, which is a 90 degrees rotation. Not a reflection, it's not flipped, it's just kind of around a circle, moves around a circle. All right, so that's a rotation. It's a little bit trickier, and the best way to do it is to think about connecting. Basically, you're making 3 circles or 3 radii that go from each vertice to your center point, and then you're moving it, and that whole radius, you're moving it 90 degrees, a right angle. Okay? So one of the things that people often say is that if you have x, y as your point, when you rotate it 90 degrees, if you do a 90-degree rotation, your x now becomes a, hang on. So if you had this, if you were rotating it around the origin, it's not always going to be the case, but let's say you were rotating it around the origin and you rotated 90 degrees, your x now becomes a negative x, but your y is still a positive y, okay? And or the other way if we went from this way to this way. So and then if you were actually going to rotate it an actual 180 degrees, bringing it all the way down 180 degrees, if you think about 180 degrees being, then basically your x, y becomes a negative x, negative y. So and you can actually rotate in 2 different directions. You can go clockwise, which goes this way, or you can go counterclockwise, which goes this way. Okay? So if you're going to go counterclockwise, you would say the positive x becomes a negative x, and but the y's still stay positive. So I don't want you to really have to worry about that too much, so don't spend too much time trying to wrap your head around that. We're going to figure out other ways that we can actually do rotations that make a little bit more sense, in my opinion. All right, so now it's time to get a little bit of practice on this. So let's take a look at my stars up here. Here I have this A star is going to be my pre-image. It's my pre-image. And I want to know which of my 3 colored stars, which of my 3, whether it's the green, the orange, or the purple, which one is a translation? Which one is a translation? Which of my stars is a translation? Well, hopefully you said that it was the orange one. This is the translation, okay? Because basically we moved this point to this point to this point. You can see that all we did was slide. We went up a little bit and over a little bit, right? Or over and up. We went probably over, I don't know, maybe 7 and up 2 or so. So you can see that we went over and up or over and up or over. All right? So our orange one was our translation. What do you think? What do you think is of these two? Let's go ahead and look at the purple one, our purple star. And what do you think the purple star is? Is it a translation, a reflection, or a rotation? What do you think? Is it a reflection, a translation, or a rotation? Well, you might have said that it was a rotation, but I'm hoping that you saw that it's pretty obvious, and you could have said it was a rotation, but what I'm really hoping you'll see is that it's a reflection. Notice that this is a mirror image. See how this one just, the light blue just flips over that line, and this becomes a reflection. So I'm going to just write reflection, R-E-F, right there for reflection. And the last one is this green one. And what do you think this green one is? Is it a reflection or a rotation or a translation? What do you think? Well, you might have said that it is both a reflection, because you could reflect it over a line here. You'd flip it over, and then you could slide it up a little bit. So it could be a reflection and a translation. Or you could just say that it is a rotation. So think about, let's go ahead and give it a point, probably maybe right about here is our center point. And if you think about from here, let's see if we go from here to here, we're kind of going this angle right here, okay? And then this one would go from here to here, and they should be about the same angle. You can see that I'm terrible at this, but it's actually rotating around this point. So this one is a rotation. Okay? Let's try this one down here. Here we've got a image B, that's our pre-image, and I'd like to know what is B, image B, to the yellow image? What type of rigid motion transformation is it? Is it a translation, a reflection, or a rotation? Well, you can see that we're sliding over and down. So it is a transformation. Okay? And what do you think this last one is, this blue one? Is it a transformation, a reflection, or a rotation? What do you think? Again, you could do two transformations. You could flip it and then slide it if you wanted. You could reflect it over this line right here so that now it's upside down, and then you could slide it. You do a translation, or you could rotate it. So think about where it would be rotating. If we took this point here and we brought it down, say to be right there, then we would take this point, and if we rotated it from there to here, you could see that that is actually that's not a very even. We need to. I'm not very good at making my center point. Maybe that's the center point right about there. So from here, rotate down to here, so you can see this arc being made. It's rotating around, so this point here becomes this point here, this point here becomes this point here. The whole thing is turning around a circle. So that, or we could again say that it is it could take two things. It could be a reflection and then a translation. So lots of different things. If it was trying to think if there's any place where we could just make it be a reflection, but I don't see it. This would have to be slid down a little bit for it to be an exact reflection. So again, lots of different ways that we can look at this, but I would say that it's a rotation from B to the dark blue. And then the last one, C. How did we get from C, this green line, to this pink line? How did we get from C to the pink line? How did we get this green line? What did we do? Did we reflect it? Did we translate it? Did we rotate it? Well, we rotated it. Here's our center point. It's the end of the two lines, and we basically took this line and we just slid it up. It just rotated up whatever this angle is. Looks like it's about maybe 120 or so, 120 degrees. It was a rotation. So that is our quick intro to identifying and describing rigid motion transformations of translations, reflections, and rotations. So it's just a basic understanding. We'll spend more time looking at each one individually, but I wanted you to be able to understand what's actually happening as you are working through these and as you do your practice. So go ahead and write yourself a key idea down here. What do you need to remember? What will help you? And I'll see you in class.